Hello, everyone. You are welcome to lesson 3 of Coordinate Geometry 1. Okay, and Coordinate Geometry 1, if you are looking at elective math, however, in core math, it is what? Coordinate geometry. Okay, so like I said, we'll do the core math aspects. Okay, and later I'll go and look at the elective math. When we get to elective math, there's really core math students you know. Okay, I will tell you. However, please, based on what we are going to do today, okay, today we'll be looking at finding the gradients of a line given its equation. We'll also look at parallel and perpendicular lines. We'll look at finding the points of intersection, okay, of equations. And we'll also look at finding equations of parallel and perpendicular lines. Okay, so this will be our main lesson objective. So at the end of today's lesson, you should know how to find the gradients of lines given, okay, their equations. And if possible, maybe the y-intercepts. And also how to find the point of intersection of two lines, how to determine whether lines are parallel or perpendicular, and how to write equations of parallel lines and whatever. So these are our main objectives. Now, the first one, we are going to look at finding the gradient of, okay, a line given its equation. And I know, once again, this is not new to you. So I'll quickly walk you through what you already know. Then we go and look at how best to use, okay, what you already know to deal with questions that will follow this. Okay, so here, they said to find the gradient of a line given its equation, we adapt the following steps. Step 1, express the given equation in the gradient intercept form. Okay, that is y is equal to ms plus c by making y the subject if necessary. Sometimes the equation will come where y is already made a subject and the equation is written in the gradient intercept form. Okay, that is 1. 2, okay, compare your results, okay, with y is equal to ms plus c. And you take the coefficient of x as gradients. So here, because we are concentrating on the gradient, okay, we know here the gradient is the coefficient of x. So when you write the given equation in this form, just pick the coefficient of x and that becomes your gradient. And the other term there becomes your y-intercept. Okay, however, like I said, our concentration, because of what you have here, is on the gradient. I've told you, immediately write it this way. Coefficient of the x will be your gradient. However, the constant there automatically becomes y, okay, intercept. So if you are asked to find the y-intercept, basically you do the same. Write it in the gradient intercept form, then pick the constant there as your y-intercept. That's just by the way. Now take note of this. Okay, you know, we said we have to take the coefficient of x, okay, as the gradient, and you have to make y the subject. But you know that in certain equations, okay, special situations, you won't get a term in y. And in certain equation too, you won't get a term in x. So if there is no term in y, how do you make y the subject? Get a point.
Yes,
So how do I, okay, find what's the gradient? And if there is no term in x, how do I get the coefficient of the x? Okay, though I can make y the subject, how do I pick? There is no s term, so how do I determine? Okay, and this will address that. So the gradient of the equation, okay, is 0 if it contains no term in x. Immediately you see your equation with no term in x, then it means the gradient is for 0. Okay, obviously it is 0x. That's why there is no term in x. It's my point well made. So the coefficient of the x, 0. And in the same way, okay, the gradient of the equation is undefined, i.e. infinity. Of course, can you see that they are the same?
yes, please.
Okay, okay, if it contains no term in y. So no term in x, gradient is 0. No term in y, gradient is what? Is infinity or undefined. Is my point well made?
Yes, please.
Okay, great. All right, so quickly, let's go and look at, okay, how best we can deal with the following, okay, question. So, find the gradient of the following lines. So here, obviously, you know you are dealing with lines, only that you'll be giving the equation of a what? Of a line. So once it's a linear, you should be able to any linear equation in two variables. Okay, only that C and D are in one variable. Okay, take it. So let's go and look at this equation, how best to help. Okay. So as usual, when you read question, make it a point to underline the CN part if any. Okay, however, with this one, you are finding just there's no CN part. Okay, like you can underline. After that, come and write solution. Write the question number. So major question number one, final question number A. So what do you do? We extract. So what are we giving? We've been giving y is equal to, okay, 3x minus 2. And if you remember the form, okay, I mean, in terms of the steps, we are told to write or the given equation in the gradient, okay, intercept form. Okay, if necessary. And you can see that, or make y the subject. So you can see that in this equation, y has been made the subject. Okay, and what you have here, this side, okay, is in partial fraction, it's not a single fraction. So you have two terms here. And you can obviously see the s term is explicit. So you can extract its coefficient to be the. It's my point well made.
Yes, please.
Okay, so in this case, that's what I'm going to do. Okay, so you can write maybe 1. And write comparing, okay, equation 1 with, okay, your y is equal to mx plus c. Okay, I can say that my gradient m is equal to what? 3. So I'll draw my conclusion. Therefore, okay, 3 is equal to the gradient. Is my point well made?
Yes, please.
Okay, very good. This will be the first, okay, question. Now let's go and look at B. B, what are we giving? Okay, 2x plus y, okay, plus 3 is equal to 0. Obviously a linear equation. So let's see here, is it necessary to make y the subject? Yes, because the equation didn't come with y made the subject. So we are supposed to make y the subject. That's the very first. If you want to make y the subject, the y term here is positive. So you maintain it here. Okay, so we are going to get, this implies that, okay, here, y will be equal to,
-2.
okay, so negative 2x, okay, then minus what? Minus 3. Okay, take notes. Okay, here, because all of them negative, okay, that's why we started with it. Everyone is possible, know what to do. So I'll call this B1 and come and write comparing, okay, 1 again with, if it's an objective question at this point, you know your gradient, you don't write this. Okay, wait. Okay, y is equal to mx plus c. You know, okay, my m will be equal to, okay, negative 2. Do you agree?
Yes, please.
Okay, so therefore, negative 2 is equal to what's the gradient? All correct?
Yes, please.
Okay, so we are left with what? The last one, C. The D will be for you. Okay, so C. What are we giving? We are giving 2y plus 4. Okay, is equal to 0. So what do I do? Okay, I can make y the subject, y is there. So I will get 2y is equal to minus 4. Okay, I have to divide 2 by 2. So I'm going to write it again because a term on this side. Okay, as you mature, you can write the gradient straight away. So I will tell you. So this will be equal to minus what, 2. Okay, but remember there is no term in x. So it means the term here, okay, y in actual fact is what? Plus 0x. Is that clear?
Yes, please.
Okay, so like I said, if you compare, in this case, I'll write therefore 0 is equal to what? My gradient. Okay, and remember I said, if your equation has no term in x, it means the gradient is 0. Oops. Is my point well made?
Yes, please.
Okay, so which is exactly the point here. Now, D, what do you think will be the gradient in D? Okay, Akosia.
Mr. Please, with the C, since you said if there's no XM, can you after you've written the given
Straight
two,
away. That's what I said. Even in my presentation, I said that you could have stated the gradient without going through this because it's a special situation. I just wanted you to know the import of that special.
yes, please, thank you.
Okay, so at this point, immediately you realize this. Right, therefore, maybe 0 is equal to the. If you want to throw more light on, you can write since there is no SPM. Right. All correct.
Yes, please.
Okay, so now D, what do you think will be the gradient?
Undefined.
Undefined. So you can write therefore undefined is equal to the gradient. Okay, so
Since
there
there's
is no
no
item.
term.
As that. How far?
Yes, please.
Great. Olali, are you fine?
Yes, please.
Okay, very good. So now, okay, we can move on to the next concept. Okay, so by the same, this time right, you can see that the equations are not that pretty. Okay, let me go back and let's only make a point there. So in this equation, okay, the y-intercept is minus 2. Though you were not asked to find the y-intercept, I just want you to. Okay, and in this equation, the y-intercept, okay, will be which value? It will be minus 2 as well. Is that clear? Your constant after making y the subject will always be the y-intercept. However, if your line, okay, has no y term, then it means the line will never intersect what your y-axis. You should know that because it's only vertical lines, okay, that will have s is equal to a particular result. And all vertical lines, there is no vertical line that intersects or meets the horizontal line, which is your y-axis, and give us a y value. Is that clear?
Yes,
Is that
please.
clear or I should come again?
Please come again.
Okay, so I think I should always add, or I should come again. All right. Okay, so this is it. That's my point. Let me go to. So if I have this, my y, my x, any line which is this way, you know will be s is equal to something, will be, okay, vertical. Okay, any line which is equal to this will be, which will have horizontal. Okay, so there is no vertical line. Once your line is x is equal to a, okay, it means your line is a vertical line. There is no vertical line which intersects, okay, the y-axis for you to get the y-intercept. Clear. The y-intercept basically means where the line meets the y-axis. So if your line is vertical, okay, it means that line is parallel to the y-axis. It can never meet for you to get the y-intercept. Okay, so if your line will meet the y-axis for you to get the y-intercept, then it should be a horizontal line or diagonal line. Vertical lines never meet. Is that clear?
Yes, please.
Okay, very good. Okay, so especially the person who said I should come again. Are you fine?
Yes, please.
Okay, great. Okay, so now I think we can move on. I just wanted you to know the y intercept. Okay, so with this, Again, we've been given equations of lines, but not that, and we are supposed to find it the same way. Okay, make y the subject, compare. Okay, I'll write the equation in the gradient intercept form. Compare and attach what value of your m as what your gradient. So now, okay, work the example 2. Okay, I. Okay, what am I giving? I am giving, okay, 1 over 3x, okay, plus 1 over 2y, okay, minus 2 is equal to 0. Okay, so obviously the equation you are making y the subject, so you have to clear the fractions. Okay, and what will be the LCM? 6, right? So we are going to multiply through by 6, which will be the same as multiply each term by 6. So once more than a term on one side, you can do that mentally. So this time 6, this will cancel the 6 and go there 2 times. So it will be 2 times s, and that will give us 2x. Is my point well made?
Yes,
Yes.
please.
Okay, then plus this one times 6. 2 will go there 3, so it will be 3 times y, so that will give us 3y. If you can't do it mentally, make sure you indicate your times 6. That will be your next step. Each one times, then you cancel to reflect this. Then minus this one also times 6, which will give us what? 12. Okay, it's equal to 0. Now what do? Maintain the term in y. So 3y is positive here. Move the other terms to that side. So that will be equal to, I want to write my positive term first. So this will be positive, this will be negative. So I'll write 12 minus what? 2. All correct. Sorry, 12 minus 2x. All correct.
Yes,
Okay, so you divide through by what? By, okay, 3. And here, because I am not going to take the whole of this as 1 and divide by 3. So I'm looking at this as 2 terms. I will divide each of the terms by 3. Because in the gradient intercept form, okay, you shouldn't have a single fraction. You should have partial fraction terms. And each term should be explicit. So this 1 over 3 will give me y. It's equal to this 1 over 3, okay, which will give me 4. This 1 over 3 will give me 2 over 3x. Is my point well made?
yes.
Okay, so at this point, made y the subject. You are mature. You can now write, therefore, you can choose not to write comparing. Okay, minus 2 on 3 is equal to the gradient. All correct. Hello,
Yes,
it's my point well made, or I should come again?
this is well made.
It's well made. All right, okay.
Thank
So now, did I hear come again? I don't know whether the person whose line is okay, a little bad is trying to tell.
Yes.
Okay. Walali, is that you? Okay, somebody's network is not helping. I don't want to believe it's Walali. Okay, so here my point is, just make y the subject.
Yes.
After making y the subject, what do? Okay, make sure the coefficient of x becomes what? Your gradient. So at this point, okay, there is an alternative method, not entirely different from what we did. Only that your algebra will change. You've been given 1 over 3x, okay, plus 1 over 2y, okay, minus 2 is equal to 0. So I'm making y the subject, so isolate the term in y. In that case, I'm going to isolate 1 over y, and that will be, okay, this time around, I will get minus what? 1 over 3, okay, x. Is my point well made?
Yes,
I
please.
Yes,
want to make y to stand alone. Instead of multiplying by the LCM, I have to multiply by 2 so that this will cancel. Okay, and the y will stand alone. Coefficient will be 1. Exactly. They are playing with our algebra. Also, so that will give me this 1 times 2 will give me y. This 1 times 2 will give me 4. Okay, this 1 times 2 will give me 2 over 3. the x. There is minus already there. So in this case, if you compare, you also say therefore gradient here is the coefficient of x, and that is minus 2 on 3. Minus 2 on 3 is equal to what? So the one that you think can adapt. All correct.
Yes, please.
Okay, very good. Okay, so we are going to move on to the II. Okay, so II, or between I and III, which one should we ask for? The one in red? Okay, it's not an option for me. No, it's really for you. I don't want to be greedy.
I.
You should do the I.
Yes, please.
Okay, all right. Okay, so it means you will try the II. So I. Okay. Hey, what are we giving? We've been giving x over 3, okay, minus y over 2, minus 1 equal to 0. So what do we do here? Again, okay, if you like, you can isolate the term in y. That's the direction I want to go. Or deal with it your usual way. Multiply through by the LCM. Okay, so I am going to isolate, but because my y term is negative, yeah, I always want to avoid. So I will isolate by moving the y to the side. Is that clear?
Yes,
So
please.
I will get, okay, and there's an equation, so I can start with implication, or I can ignore, like I ignored here. Okay, so you isolate, so you get x, and this is the same as 1 over 3x. I want the coefficient to be expensive. Minus 1 is equal to y over 2. All correct. So again, the y coefficient you want it to be 1. So if you want it to be 1, you have to multiply this by data, which is 2. Then each of the an equation, whatever you do to any particular term, you have to use all the terms just to keep equal to sign. So it means it will be this 1 times 2, which will give me 2 over 3, okay, x. This 1 times 2 will give me minus what? It's equal to this 1 times 2 will give me y. So now you can compare the coefficient of x here. It's this, and that becomes a gradient. So therefore, okay, 2 on 3, which is the coefficient of x, is equal to 8. Are you all fine?
Yes, please.
Okay, great. Okay, so that will be it for, okay, finding the gradients, okay, of any given item. Okay, Lynette.
So I don't remember like who said this, but someone was like, when you have like when you're concluding like this, like instead of writing like 2 over 3 is equal to gradient, you write like gradient is equal to 2 over 3. I just wanted to like confirm.
Okay, so remember, I said in every math statement, if your conclusion will involve English and math, write the English, sorry, the math first. Okay, and you can see that
Yes.
if you write therefore 2 over 3 and they say stop work, what you are looking for is this value. You stated that there. And if you write therefore gradient and you don't write this, okay, the value that we are looking for, have you stated it?
Oh, please.
No, so you get the point. So always write the
Yes.
math first, followed by the English.
Yes, please.
So maybe you were asked to find equation, just like the coordinate geometry one. Oh, sorry, even the, yes, the one. You were asked to write equation. Remember, we just write the equation and write therefore. Write therefore the exact equation. I said you can add is the equation or ignore. But if you want to write the English first, then you have to write, okay, therefore the equation is, okay, therefore the equation stop work. What is important? You didn't write it. You get it? So you won't get a
Yes,
full
please.
stop. So always, whenever you are computing, you have maths and English. Write the maths first, followed by the English. The English will always be a buffer.
Yes, please.
Great. All right. Okay. So now this will be it for this. Okay. So now let's go and look at our next concept: parallel and perpendicular lines. Okay, parallel and perpendicular lines. And I think mentioned this before. This is also a concept that JHS. So I'm only going to read what you have there, which definitely will ring a bell. And I know you know as well. So quickly, let's look at, so two lines, A, B, and C, D are said to be parallel if they have the same gradients. So anytime you want to determine that two lines are parallel, you have to use gradients of the line. That's what you use in making that determination. So that is if line AB is parallel to line C, then MAB, the gradient of AB, should be equal to MCD, the gradient of the line C. You get it? So the mass statement that we have here is what in terms of. Is my point well made?
Yes, please.
Okay, very good. Okay, so now again, let's look at the whole of this English statement that we have here. Get it corresponding. So for perpendicular lines to be the condition. Okay, so two lines again, A, B, and C are said to be perpendicular if the product of their gradients is -1. Okay, I should have put in brackets, okay, -1 as a figure. Or their gradients are negative reciprocal of each other. Okay, I will come to that. I think in one of our lessons, somebody did this. Okay, so that is again in terms of math. If AB and this is perpendicular, you can use it just as you can use this for parallel. Geometry is universally accepted. Okay, it's perpendicular to us. Then the product of also the gradient of AB, the line AB times the gradient of the line CD, that's the product of these two gradients, should give you -1. Take note, it shouldn't be 1. It should give you -1. Is that clear?
Yes, please.
Or we said, okay, they should be negative reciprocal of each other, and that will come from this statement that you have here. If you make MAB the subject, you are going to get, okay, M sub AB, okay, is equal to 1 over M sub CD. Do you agree? Do you agree?
So it's going to be -1.
Very good. So you don't agree. Okay, so it's supposed to be -1. Be very careful of the negative. Exactly. Remember we said it will be negative reciprocal, not the reciprocal. So be very, very careful. Or if I come and make CD the sub MCD the subject here, get MCD sub CD to be equal to -1 over MAB sub AB. Okay, and again you can see that okay, these two gradients are negative reciprocal of each other. Afa. Hello, is our point well made?
Yes, please.
Yeah, great. Okay, so okay, all right, should come again.
Yes, sir, please come again.
Okay, all right. So which part do you want me to come again? You get this one, is that not it?
Yeah, no, the second one.
This part. Is it this part
Yes,
or
sir.
this part? The product is equal to -1. Do you get this part?
Yeah, the product is the product one.
This one, the product. It's just a fact. So you need to know this fact. Just as you need to know this fact that the gradient should be equal before they will be parallel. You should also know that for them to be perpendicular, the product of their gradient should give you 1. Okay. So all that you need to know along the line, okay, we'll prove this. So don't worry. But for now, take it as a formula. Okay, or as a relation. Okay, whenever you are dealing with a perpendicular line. So if you appreciate this, okay, then what you are supposed to do is make one of the gradients here the subject. So if I make AB the subject, then it means I have to divide through, okay, on both sides by MC. And you see that if I make MAB the subject, then it means it will be this one over MC, this one over MC. So that will give me MAB to be equal to -1 over MC. You get the point?
Easy.
Yes, please.
And the same for this one. If I make this one the subject, I have to divide both sides by M sub A, and that will also give me -1 over this. So you can see that MC is the negative reciprocal of MAB. Okay, and MAB is the negative reciprocal of MC. It means they are negative reciprocal of each other. Get the point? Okay, Alan, are you fine now?
Yes, please.
Great. Okay, so now let's see how best we can make use of the concept that make this determination. So our first write the example, determine whether or not the line AB is parallel of lines. So here you are not giving, so you are giving points. Okay, A, B, C, A, C, D. Okay, for all that. Okay, so let's look at how best we can solve this. Okay, quickly, let's go to the solution side. So solution, what do you want to determine? Parallel or perpendicular? So parallel. Okay, so major question number 1. Okay, minor question number 2. Okay, we extract. So giving A, okay, which is 3, 1. Okay, B, okay, which has the coordinate 4. Okay, then C with the coordinates, okay, 4, 2 as well. Okay, then D with the coordinates I'm at. Okay, no problem. Let's work with it. Okay. And one other than the question sense. And okay, okay, will be 5, 3. And the reason why I'm saying that the question is not making sense to me is that E and C, same point, usually won't give it different names. Is my point well made? But assuming this is the question we are going to work with, all correct?
Yes.
Okay, so now what do we do? You want to find, we know, in order to determine that lines are parallel or perpendicular, what is it not their gradient? Okay, so we are going to find the gradient of AB and the gradient of C. We know how to find the gradient given 2 points. So I'm going to write that the gradient of AB, so the M sub AB will be equal to, I know it will be changing Y over changing X. So you can always do that mentally. I've told you as you mature. So that would give me 2 minus, okay, 1 all over 4, okay, minus 3. Okay, so that in effect, I come to the margin here. 2 minus 1 is 1 all over 4 minus 3 is 1. Okay, so in effect, I have 1. Is my point well made?
Yes.
Okay, you could have moved from here to this straight away. This will not attract any marks. Okay, now, and you need to go and find the gradients of the other one. So M, C, and the C, D, A, B, they are all capital letters. These points are denoted or represented by capital letters. So that will give us change in Y. Okay, so it means this is your X sub 1, Y sub 1, S sub 2, Y sub 2. So Y sub 3. That's Y sub 1 all over, okay, what do you call it? X sub what? 5. Next what? X sub 1, and that is 4. So that will also give us 1 for 1. So you don't write over 1. Okay, 1. So at this point, so let's see. If they are the same, it means the lines are parallel. The product gives you -1, and the gradient is the same. MAB is 1, MCD is 1. So are the gradient the same?
Yes, please.
Okay, so once they are the same, you know the obvious conclusion. So right, therefore, the line AB is parallel to the lines. Okay, and if you like, you back it with the resistance. Okay, MAB, the gradient of AB is equal to the gradient of what? CD. All correct. Is my point well made?
Yes. Yes, please.
Okay, so let's go in that of them. Okay, so B, what are we giving? The reason why I didn't want to write the give, but I realized that the whole of this would not go there. That's why I didn't write the give. Okay, it will not affect it. So again, I'm going to write my A. I'm 2. Okay, it's what 4 negative. My B, okay, will be 5. Okay, negative 5. My C, okay, will be 1, 3, or it's 3, it's 1, 3, and okay, my D, okay, is what? Negative 2, negative 4. All correct. Okay, so you need MAB, MCD to make that determination. So let's go and find MAB. In this case, okay, MAB, can choose not to write the bat. So M sub A is equal to change in Y, so it's Y3. So this is X1, S2, it's X1, Y1, okay, S2, Y what? We are going to get Y2 minus 5 minus Y1, Y1 is X minus, it's minus 2 and S minus. That's correct. All over your X5 plus your X1, S1, 4. Okay, it will be minus 4. So at this point, we are going to get this to be equal to, okay, minus 5 plus, that would pass minus 3. Okay, 5 minus 4 plus 1. I will write to know the value of M. And okay, M sub C will be equal to now S sub 1, Y sub 1, S sub 2, Y sub 2. Okay, remember this. Okay, so we are going to get negative 4, which is our Y sub 2. Okay, then minus what? 3. Okay, so which is our Y sub 1 minus 3. All over. Then you come here, negative 2, which is the S sub 2. Okay, minus, okay, our X sub 1, which is what? Which is 1. That would give us 1. In effect, we are going to get this to be equal to minus 7. Am I right?
Yes, please.
Over minus 3. So I'm going to get, okay, 7 on what 3. All correct.
Yes, please.
Okay. So at this point, let's look at the two values in terms of the gradients. MAB is equal to MCD. Obviously, no. Now let's see, it means the lines are not parallel. They are not parallel, then it means the lines, however, if they meet at an angle of 90, the special, okay, meet, that is your, that of the what, 1. So you know 3 times 7 on 3. But minus 3 times 7 on 3. You what? Minus 7, not minus 1. It's my point well made. So again,
Yes.
lines are not perpendicular. It means MAB is not parallel to MCD, and MAB is not perpendicular to MCD. So that's what we are going to write. So therefore, okay, M, oh, not M. It's not the gradient that is parallel. Okay, take notes. It's rather the line. That's therefore it's the lines. Okay, so let's pick the lines. Therefore, my line AB, okay, parallel is this. Okay, parallel is this. No, if equal to is this. How do you write not equal to?
You pass a diagonal line.
You cancel it.
We
Sort of.
cancel it. That
Okay, with the diagonal. So the same to not parallel. Cancel the parallel line. Far. That's my point well made. And okay, AB, okay, perpendicular is this. Perpendicular to, okay, CD. Okay, so if perpendicular is this, not perpendicular, that's okay. Safa.
Yes, please.
Okay, so neither are they parallel or it means they intersect, only that they will not intersect at an angle of 90, making it perpendicular. Okay, so we move on to what? That of the C. Okay, then the D. Okay, so C. What are we giving? We are giving A. Okay, 2, -2. B. The point B, -1, -4. Okay, the point C. Okay, -3, 2, and the point D, negative, so 1, -1. Okay, I'm going to pause here, find the gradients. Okay, then you come and look at it. Okay, together. So let me pause. You are going to find M, AB, the gradient of AB. You are going to find the gradient of AB yourself, that of CD yourself. When you are done, then we come and compare our answers. Okay, so finding the gradients of AB and CD, we ended up getting these two. Okay, so again, you can see that okay, they are not equal, and the product will need give us -1. If this resulted in -3/2, then the product will give you -1. Is my point well made? In that case, you say that the lines AB, okay, and CD are okay perpendicular, or AB is perpendicular. You use the notation, a symbol to for perpendicular, okay, and to CD. You draw your conclusion. In this case, again, therefore, okay, the line AB, okay, is not parallel to the line CD, and okay, again, the line AB is not perpendicular, okay, to the line CD. Okay, all right. So the D will be yours, okay, okay, so when we come back, we look at our next, okay, concept. Okay, and I think let's finish this. Okay, still on the perpendicular and parallel. Let's finish this. When we are done, then we have our water break. Okay, so quickly, okay, let's see. Unlike the previous set of questions, okay, or the previous question, you realize that you were given points and you could find a gradient from points. The same way, if you look at this, you are given what? Lines. Okay, the equations of lines, and you are supposed to determine whether the lines that you have there pair. Okay. Okay, and don't have point to get the gradient, but once we know the line, remember where we are coming from, now know how to find the gradient of any line. Okay, from its equation. Is that clear? Okay, so let's see how best we can look at this question. So as you are, okay, what do we do? Solution, major question, normal question, final question, A. Okay, you've been given two equations, so this is how you extract. I've told you, but anytime you are given more than an equation, immediately you extract, you label that equation. So take note. So this will be called equation 1. Okay, and okay, your second equation will be y is equal to 2 minus 3 what x. Label this as equation 2. All correct. Now we need to find or take each equation and find its gradients, and we know how to find equation, okay, of a line given, and okay, I mean the gradient from given equation of a line. What do we do? Take that equation, make y the subject, and if necessary, then compare. So I will write from equation 1. go and write making y the subject. What you tell us that you are making y the subject. So y is positive here, in it here, that's equal to move this one to the side. So I will get 4 minus 3 what x. So this implies that here my m, and I'm going to call it m sub 1. That's the gradient of my first line, and that will be equal to minus 3. Is that clear?
Yes.
Okay. Then from go to your second equation. Thankfully, your second equation, you can see that it is already in the gradient intercept form. So you can extract the gradient straight away. So m sub 2 will be equal to minus 3. All correct?
Yes.
Okay, so now we can see clearly that, okay, your first equation, its gradient being negative 3. The second equation, okay, shares the same gradient, negative 3. So once they have the same gradient or equal gradient, you know the conclusion. So therefore, okay, here, okay, you cannot use what? The name of the line. Okay, I'm talking about A, B, C, D because we're not giving. So you just write there for the lines all correct. And if you like, you can choose not to write parallel this way and use the notation allowed. Is that clear?
Yes.
Okay, so maybe we'll do one more and we're done. The other question you should be able to do. So P. Okay, what are we giving? We've been giving, okay, y plus 1 is equal to 2x. That will be my equation 1. And okay, my second equation is what? X plus what? 2y is equal to 12. Equation 2. Okay, so now again from 1, okay, y is not already made the subject, so we will make y the subject. So y will be equal to 2x minus 1. This implies that I m sub 1 equal to, okay, 2. Then let's go to our second equation and get the gradient of that line. So equation 2. Okay, so yes, y is not made the subject, so we are going to make y the subject. We are going to get, okay, 2y is equal to minus, or let me write 12 first, write the positive first, x. Okay, we write it again before we, if you want to take the whole of this, okay, as a term. However, I am going to divide each one by the 2 because of the form. The terms must be explicit. So this 1 over 2 will give me y, okay, is equal to, this over 2 will give me 4. Sorry, 6. Okay, then this over 2 will give me 1 over 2x, or x over 2. I want my gradient to be explicit. So I'll write, this implies that m sub 2 is equal to minus 1 over 2. All correct. So here, the gradients are not, okay, the same. So it means obviously the lines are not parallel. They will meet. Now let's see whether they meet at an angle of 90, making it perpendicular. If they meet at an angle of 90, then if you multiply these two gradients, you have to get negative 1. And you know, 2 times minus 1 on 2 will cancel and give us negative 1. So it means the lines are what?
Perpendicular.
Perpendicular. Very good. So you write therefore the lines are perpendicular. Let me use the notation so that you also learn to do that. Okay, you take the English out. Okay, you give the English to your English teachers. We need the math. Okay, so perpendicular. Alpha. Okay, so if that's the case, then okay, at this point you have our water break. Okay, so welcome back from the water break. Now you know how to find, okay, or determine whether lines are parallel or perpendicular, whether you are giving the points, forming the lines, or you are giving the equations of the lines. Okay, so let's go and look at our next concept. Okay, and that will be finding the point of intersection of two lines. Okay, I know, okay, that whenever you are asked to find the point of intersection of two lines, okay, or whether a line in a circle or what have you, point of intersection in terms of mass, okay, you have to solve the system of equations simultaneously. That's the method that you know, true or false. Okay, so you know you have to solve the two equations simultaneously. Okay, and we have the graphical approach too, but you know they are not using graph here. So the simultaneous equation will be the best way to go. Okay, however, I'm going to walk you through the second method. We'll do the two and see which one, okay, will be ideal. Sorry. Okay, so now, method two, this is what we are supposed to do. Method one is just about you solving a system of equations, okay, simultaneously, either using the elimination method or the substitution method. Okay, method one, okay, explained your usual way. Now, method two. Okay, so step one, express the two equations, okay, for the lines or of the lines in the slope intercept what form. So you have to make, okay, each equation, in each equation, make y the subjects. So write it in the slope intercept form, which we know, the gradient intercept form, where we are coming from. You've done that. Then after that, set the two equations for y equal to each other. So your first equation will be y is equal to. The second equation will also be y is equal to. So if y is equal to a and y is equal to b, then it means a is equal to b. That's all that you need to do. Okay, and your resultant equation will be in terms of x. Then you solve for x. After solving for x, you use this x coordinates and substitute it into either of the original equations of the lines and solve for y. As simple as that. Okay, so okay, maybe the first two questions will use method 1 and 2. Okay, maybe, but at least I know that the first question I will do. Okay, all right. So let's look at this question. Find the points of intersection of the following pairs of lines. Okay, so what we have here, quickly, let's go and look at what? The solution. So we are finding the point of intersection. Find the points of intersection. So it means your answer must be in the point form. Okay, so quickly, let's see what we are supposed to do. Okay, so question didn't come with any major question number, but we have a minor question number A. Okay, what are we giving? We are giving x minus y equal to 1. Remember, okay, one equation, you label it. And, okay, our second equation will be 3x plus 2y, okay, is equal to 8. We label this as, we are going to use method 1. Okay, so method 1. Okay, so for method 1, we are going to solve these two equations simultaneously. Okay, so now, okay, which method will be better? If elimination is the ideal method to go, then the variables, okay, should be easily eliminated. Okay, meaning the coefficient should be the same, but not the same for x, not the same for y. So substitution maybe will be the best way to, because if you make x or y the subject, it will not involve a fraction. So I will come and write from equation 1, I will make x the subject. So in that case, I'll write x is equal to 1 plus y. Okay, I'll call this one a. And go and substitute 1a into what? Into equation 2. So 1a. I hope you are following my professors.
Yes, ma'am.
into equation 2. Okay, remember this will always be too short, just like the from 1. It will be too short to take a line. So write comma, semicolon, or colon, and put. But don't leave anything, don't leave it empty like that. So comma, okay, then 1a into 2. So whenever I see x here, it is 1 plus y. So it will be 3 into 1 plus y. Okay, then plus 2y. Okay, is equal to 8. So now what do? We expand. You get 3 plus 3y, okay, plus 2y is equal to 8. Okay, so this gives us 5y is equal to 8 minus 3, which is what? 5. You write it again before you divide. Is my point well made? However, it's
Yes,
a point.
ma'am.
We are looking for a point of intersection. The question asks you to find only the y coordinate that would have completed here. And we need, okay, the point. The point is made up of x and y coordinates. Know the y, so we use the y to that will give us what? Okay, equation 3. And equation 3 into the one that you need as the subject. So it will be 3 into the one that you need as the subject, which is this. So equation 1a. And that will give us x is equal to 1 plus 1. Okay, so that will give us x to be equal to what? 2. So you draw your conclusion. Therefore, the point of intersection is no. Write that point of intersection first. That's the part. Okay, 2, 1. Okay, is equal to the point of intersection. Is my point well made? And please, these two, they don't move together. Is equal to. It's either you write is or you write equal to. They don't move together. In maths, is equal to. Is my point well made?
Yes, please.
All right. Okay. That would, so I can write here as well. And when I write it, then okay, wait, what? Point of intersection, not this point of intersection. Okay. I don't know whether okay, you can write that now. They've changed the syllabus. All right. Okay, so it's my point well made. So let's go and look at the method 2 and see which one is comfortable. Okay, for us to use. Okay, and we adapt. Okay, so quickly method, okay, 2. Okay, method 2, this is what we are going to do. We said from each equation, okay, you have to express it in the slope point, okay, form, or, sorry, slope intercept what form, okay, or gradient intercept what form. So now what do? I will go and write from 1. I'm going to make y the subject. Because making y the subject is something. So y will be here. My mind, I'm moving y to the side. I'll write it there. Equal to. Then move this one to the side. So x minus 1. Is my point well made?
Yes, ma'am.
Okay, so maybe I can call this one a. Okay, from 2. Again, I go and make y the subject. So here I maintain this is positive, so I'll get 2y is equal to, move this one to the side, so that will give me 8 minus what? 3x. Okay, now what do? I write, okay, 8 again and divide both sides, but I want to divide individually. Okay, doesn't really matter. Here, you are not extracting the gradients, so you can divide the whole of that by 2. Take note, and that's what I'm going to do. Is my point well made? Is the gradient that when you need a gradient, you have to write the terms as explicit. But here, I'm not interested in the gradient. I just have to make y the subject. So you shouldn't follow any form. Okay, or like I said, If you still want to write it in the point intercept form, you can do that. Sorry, gradient intercept form, you can do that. Not the point intercept, gradient intercept rather. So I am going to equally write it in the gradient intercept form because of the step that you were. So that will give me this over 2. That will give me y is equal to this over 2. That will give me, okay, this over 2 will give me 3 on 2x. Is that clear? So this becomes equation 2. Is my point well made?
Yes, please.
Okay, so now at this point, y is equal to this. The same y is equal to this. So this must be equal to this. Yeah. If y is equal to a and y is equal to b, then it means a must be equal to b. As simple as that. So far. Is my point well made? My professors, are you there?
Yes, please.
Okay, one of you is missing. Let me see who is missing. I think it's Walali. Okay, who is Moto G10?
Mr. Akman, please me,
I
Bushra.
see, yeah, I think I should remember. Anyway, all right, so that's it. I hope you are following, Bushra. Okay, so at this point, all right, this implies that, okay, I'm going to equate the two. So x minus 1, okay, will be equal to 4 minus 3 on 2x. So what do we do? Clear the fractions. There's an equation in only x. We are going to solve for s. Clear the fractions. So each of the terms times the LCM, which will be 2. So it will be 2x minus what? Minus 2 is equal to 8 minus 3x. Okay, you move this one to the side. So 5x is equal to what? How come? Okay, so let's move on. It's equal to, is it 6? It's like something is wrong somewhere. Okay, let me see. This times 2, this times 2. Okay, let's move on and see. So this plus that will give you 9. You remove this one to the side, will give us 5. This will give us, 10 rather. Forgive me. I thought, okay, so we are right. There is nothing. We are finding the s first. Okay, so you write it again for 5 over 10. So sorry, over 5 over 5. So x will be equal to 2 here. You can see that it's the same s value. Then now what do? You call this equation 3 and go and substitute into this equation. And you get 2 minus 1. And that will also give you, so let me squeeze that one here. Okay, or we have a next page. I will go to the next page rather. It will be better that way. Okay, I won't do, after this, if your understanding is okay, I won't do anymore. We'll move on to our next concept. Okay, so, okay, quickly, let me pick. Okay, so we are going to substitute 3 into 1a. So let's go and do that. Okay, so write equation 3 into equation 1a. And that will give us y is equal to x, which is what? 2 minus 1. So it means y be equal to what? Be equal to 1. So you draw your conclusion, therefore, okay, your x coordinate is what? 2. The y coordinate is 1. So that's the point of intersection. Afa.
Yes, please.
Okay, very good. Okay, so with this, do you have to do one more? Or our understanding is okay? Just solve the two equations simultaneously. That's all. Whether by expressing them in, okay, y, so that you can equate the two y's. Okay, or use elimination substitution method. That's all. Okay, so we won't do, okay, another one. We are going to, with this one, we've exhausted, okay, all that we need to do. Okay, great. Was my line breaking at a point?
No, please.
Okay, because I just had a feedback that my network is not stable. Okay, but no problem. If it's stable, then we can move on. So I'm going to skip that. So this will be would this be, yes, the point of intersection is what we've done. Okay, and even with the point of intersection, let me go back. Okay, the question can ask you, okay, I can still be here and make my point. The question can ask you to find the S coordinates of the point of intersection. If the question asks you to find the S coordinates, okay, and you are using solving by simultaneous equation, please, this is what you do. If you are using elimination, eliminate Y. So that straight away you solve for the X. If you eliminate X, then you have to find Y before you go and find X, which will be a waste of time. Because with this one, we are only interested in the X. So find the X first. Is my point well made?
Please come again.
Okay, I said, assuming maybe the question said, here you were asked to find the point of intersection. So meaning you need to find the S coordinates and Y coordinates and put them together as a point. S value, Y value, put them together as a point. However, you could be asked to find the S coordinates, okay, of the point of intersection of the two lines. So it means the question wants you to find the X or solve for X when you are solving them simultaneously. So don't go, and if you are using elimination method and you are solving for X, eliminate Y. If you are solving for X and you are using substitution method, okay, please substitute for what? For Y. So meaning make Y the subject so that when you substitute the X. And you solve for X. Is my point well made?
Yes, please.
Okay, so that will be it. Okay, otherwise you go and work. Okay, for now to remember, you to, okay, work smarter, not harder. All right, so now let's look at the equation of, okay, parallel and perpendicular lines. So the equation of a parallel line is given by this formula, the usual point-slope formula, parallel lines. Okay, equation of a perpendicular line, now you know, okay, if the gradient of the original line is M, okay, the gradient of the perpendicular line is reciprocal of what? The original line, so it's minus 1 over M. So perpendicular lines will have, okay, this as the formula for finding it. Perpendicular will be this, parallel will be this. Take notes. So anytime you are finding the equation of a perpendicular line, you put this parallel line and use. So where M is the gradient of the given line. Is my point well made?
Yes.
Okay, so maybe going forward, you appreciate better. So let's look at our first question. Find the equation of the lines which are parallel to the given lines through the point stated. Okay, so this is your line. This is what's the point. You are finding the equation of a line parallel to this line, okay, and passing through this point. And you know, if you want to get the equation of a line, you need the gradient and what's a point. You've been given a point directly, but the gradient is not given directly. And get the because it's parallel to, no, every line and okay, a line that is parallel to, they will share the same because parallel lines of the point well made.
Yes, please.
All right, correct. Now let's move on. Okay, how to deal with the questions that we have there. So solution, question 1. Okay, we want to find the equation of the parallel. Very important. Through the point stated. So we've been given, let's extract our line. It's equation 3 minus x. Label this as equation 1. And not giving a point. The point is what? Minus 1, okay, minus 3. The reason why you label that equation, okay, 1, is that you need it to extract the gradient. Is my point well made? Okay, so this question, okay, involves a formula. We are looking at power lines. So what's the formula for the power lines? Equation of, okay, power lines. Okay, you know, it's given by y minus y1 is equal to m into what? X minus x up 1. My point well made.
Yes.
Okay, so now what do we do? Okay, we need our m. So we are going to find m and find it from this line. So come and write from 1. Okay, you know your m equal to, okay, minus 1. Is my point well made? The coefficient of x here is minus 1. So you come and substitute that one and x1, y1 into this. All right, this implies that, okay, y minus y1. Y1 is minus 3, so plus 3. It's equal to m minus 1 to x minus x1, and it's minus 1, so plus 1. But we are going to get y plus what? 3 is equal to minus x minus 1. Remember, your equation must be in the standard form unless otherwise stated. So you move everything to one side. Start with the s term. It's negative. So that would be x. Okay, then the y term plus y. This will move 3 plus 1. That will give you 4. Okay, it's equal to 0. So therefore, this will be the equation. Is my point well made?
Yes. Yes.
Okay, we are going to do the B. Maybe a second one. Okay. Then C plus. So B. Okay, what are we giving? Okay, the equation 2x minus y, okay, is equal to 5. Okay, that will be your equation 1. And we've been given the points. I want to use comma. Okay, remember I've told you in math, a comma can also mean end. Okay, so the point is what? 1, 0. So in this case, from 1, okay, I will go to the formula first. The power line equation is given by, okay, I realize that the other one didn't go there. So I will come down. If you know, okay, so you do the right thing. So that will give me y minus y1 is equal to m x minus x up 1. Okay, so that's, okay, or two. So from, let's go and get the gradient from 1, which is 1. We are going to get the gradient, move this one to the side. So in my mind, I'm moving it to that side. So to y is equal to, bring this one here, so 2x, okay, minus 5. So this implies that my m will be equal to, okay, 2. So now, which point am I going to use? I'm going to use this point, x1, y1, you know your gradient as well. So this implies that when substitute y minus y1, y1 is 0 is equal to m, which is 2, 2x minus x1, and x1 is 1. Okay, so you get y is equal to 2x, okay, minus 2. You know, okay, everything should be on one side, equated to 0. X term first, what must be positive is positive here. So I will move. So in my mind, moving this to the side. So I'll write 2x minus y, okay, minus 2 is equal to, okay, 0. So therefore, this will be the equation. Is my point well made?
Yes. Yes.
Okay, so with this, you should be able to do that of what? C. Okay, at this point, let me pause and ask you individually whether